Okay students, this is a geometry question. Let me draw the circle. I don't have to draw the circle in the exam. I'm drawing this so that you'll be in a better position to understand. Okay, so we got the circle. Now what I wish to do is I will have to draw the diameter. Okay, so this is the diameter, and let me take this point as O. Now you have two semicircles. Now this semicircle is actually holding a triangle. So and then we got another figure. Okay. So this is S, this is A, this is W, F and K. This angle is given as 62 degrees. This angle is given as 54 degrees. These two lines are parallel. What we are asked to do is, we are asked to find angle FAW. This is the first angle we are asked to find. FA, we need this FAW, right? FAW. Okay, now this is a very important point of observation. I'm going to state it. Now you see this SW is the diameter. Is the diameter of the circle, and the diameter subtends an arc SAW, which form the vertices of triangle SAW. Now when this happens, okay, this would mean SW is one of the sides of triangle SAW. This is a very important point you will have to focus. Now what is that? Now whenever the diameter holds a triangle In other words, a semicircle containing a triangle such that one of its sides forms the diameter of the circle. Then this would mean one of the angles in the triangle of triangle SAW will be equal to 90 degrees. Now from the figure clearly these two angles cannot be 90 degrees. So the only probability, the possibility is this is going to be 90 degree. Okay, so having mentioned that, this would mean this is the required angle, right? FAW, angle FAW. So angle FAW will be equal to, from 90 you take away 54. This is 90. From 90 you take away 54 degrees. So what happens? 90 and 54, 10, 6, you have 8. From 8 you take away 5, you get 3. Okay, so this is equal to 36 degrees. So this is angle FAW. So that's the solution for this question. Now the next part is we are asked to find angle SKF. S, K and F. Now consider this diagram SKFA. What is that? It is a quadrilateral. Now this quadrilateral is actually inscribed inside a circle. So that means this is a cyclic quadrilateral. So I'm going to state that. We observe that SKFA is a cyclic quadrilateral. So that would mean the opposite angles are supplementary. So that would mean angle at A plus angle at C or angle at K will be equal to 180 degrees. That means angle at A plus angle at K is equal to 180 degrees. We need angle at K, so angle at K is equal to 180 degrees minus angle at A. So angle at K is 180 minus 54. So from 180 you take a 54, 10, 6, 7. From 7 you take a 5, you get 2. So 126 degrees. So angle at K is equal to 126 degrees. So that's the solution. Now this is the final part. Final part, they are asking us to find A, S, W. So we need this angle. Now clearly you see that SK and AF are parallel sides and are opposite to each other. So I'm going to state that since SF, or I would say SK, since SK and AF are opposite and parallel, so this would mean angle ASW plus 62 plus this angle 54 will be equal to 180. So this is equal to 180 minus this is 6 and 11. So from 180 you take away 116, 10, you get 4. From 7 you take away 1, you get 6. So angle ASW is 64 degrees. That is the conclusion for this question. We move on. Okay students, this is the next question. Let me draw the figure. This is a bearing problem. Okay, this is PQR. This is 120 km, 150 km. So PQ is 120, PR is 150, angle QPR is 23, QPR is 23. We have to find QR. I will utilize the cosine rule to get QR using cosine rule. So that is going to be QR squared is equal to PQ squared plus PR squared negative 2 times PQ times the PR times the cos of the angle, cos 23. You can use your calculator. This is 120 squared, 150 squared, 2 times 120, 150 times cos 23. So 120 squared plus 150 squared, 36900. 120 times 150 times 2, 3600. Now you have cos of 23, that is 0.9205. Okay, 0.9205 multiplied with 36000. This is 33138, 36900. So 36900 negative 33138, 3762. This is Q R squared. So QR is equal to root of 3762. So square root of 3762 is 61.34. Everything is in km, so that will be the solution. Okay. Now if they ask you for one decimal place, you just give it as 61.3. Now they are asking you to find the area of PQR. This has a formula as half into AB into sine theta. So half times 120 into 150 into sine of the angle between them, sine of 23. So 120 times 150 divided by 2, 900 multiplied with sine of 23, and I'm multiplying it with 900. So this is area 3516, one decimal place, 0.6. I'll be taking this 0.6. Okay, 0.6 square kilometers. Km squared. So that is the area. Okay, now that completes the first part. Now you have the other part let me show you the other part. The other part is we are asked to obtain the bearing of R from P. The bearing of R from P. So what is the meaning of this? That means from P you are looking at R. What are we given? We are given the following. The bearing of P from Q is 252 degrees. That's all we are given. That means from Q you are looking at P. Now what I want to find out is, I want to find out the bearing of Q from P. That means initially you are standing here and you are looking towards P. Now you have to stand in this direction and look towards Q. So for that, this is required from P to Q. So the angle given is 252. So what you have to do, from here you take away 180. So 252 you take away 180, what do you get? You get 2, and 15 you get 72 degrees. So this is 72 degrees. Okay, so that's the first part. Now we are asked to find out the bearing of R from P. So that is required. Now where is R? R is at the right side. Right side means always you add. Right hand side means always you add. So therefore the bearing of R from P is, what do we get? 72. What is the angle? 23. When you add, what do you get? 95 degrees. So that's the solution. So this is one part. This is the next part. Okay, so we move on.